Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X, the cause behind CMEs. Now, the dead or energy depleted stars and planets, which are members of the Planet X system, which has been invading our solar system since at least 1643, are often observed moving away from the Sun within CME, which stands for coronal mass ejection plasma. I also refer to these objects as stellar cores because they lose their outer layers of material until their cores are exposed, indicating that all celestial objects have the same basic design, and the greatest difference between stars and planets is their size, as both generate energy in their cores through radioactive decay and emit light from their atmospheres. A star is able to emit much more light because its greater size leads to a much stronger electric field in its atmosphere, which places its atmosphere in plasma arc mode. And you may look at article 283 entitled Planet X, Planets, Stars, and Black Holes for more details. Now here you see one of these stellar cores moving away from the Sun in this cactus image, and it is enveloped in CME material. You can see some of this material around the object. And here's another one. This is in a stereo A core 2 image, and you see the object here also enveloped in CME material. And this image from November 30th, 2017, this object was about half the size of the Sun and therefore 5 times the size of Jupiter, so quite a large object. And this one was even larger, about the same size as the Sun. The size of the Sun is indicated by the white circle on the occulter. And I actually measured the speed at which this object was moving, and you can see it is within the CME plasma, and it was moving at about 700 kilometers per second. So for details on that, you may look at article 67 entitled Stellar Core Gravitation and Eris. This one is even larger. This one was about 4 times the size of the Sun. I first estimated it to be at least 3 times the size of the Sun, but it turned out to be 4 times. You may look at article 265 for details on that. And you can see that this object is enveloped in coronal plasma, in plasma that seems to have come off the Sun. So again, it's what we usually call CME plasma. And this plasma, which seems to be draped across the object, you can see it here, actually made it possible for me to estimate its size, because it means that it must be very close to the Sun. And here's an even larger one. This one was about 7 times the size of the Sun, and it appeared in this LASCO C2 image from 2014. It was sent to me by Owen Steiger, and we can see that the Sun seems to be having a strong reaction to the presence of the object, and it is as if there is all this coronal plasma moving or being issuing from the Sun and moving towards the object. And you can see some of it actually in front of the object, and we can thus place it extremely close to the Sun. So it seems that they in this image, what we see is large amounts of coronal plasma issuing from the Sun in the direction of the stellar core, suggesting that the object is drawing the plasma from the Sun. And here we see another one of these stellar cores. This is a striped object, and the stripes are actually curved and thus conforming to the spherical surface which this object has, thus clearly indicating that it is a solid object. And obviously this object is drawing material behind it, which can only come from the Sun's corona. So it's drawing a coronal plasma from within the corona. Now, the fact that these objects are so often observed within CME plasma as it moves away from the Sun at high velocity can only suggest that the objects themselves are responsible for the CME events. In addition, the objects are often also observed drawing a trail of material behind them, as we see here, and the smaller ones are observed to have gravitational vortex connections with the sun. That is, the ones that are observed within the sun's corona. And this vortex is a connection between these objects and the sun, and through these gravitational vortices they are able to draw material from the sun, and this material seems to actually come from the chromosphere, which is a denser layer, most likely a liquid layer in the sun. So if the objects obviously draw material from the sun through their gravitational influence on it, should we not expect the larger of these objects to be able to pull away from the sun large amounts of coronal plasma, and possibly also plasma from the sun's chromosphere? In other words, the CMEs seem to be the result of the objects exerting a gravitational force on the sun, which results in material being drawn from the sun toward the objects, and this material then becoming trapped by the object's gravitational influence and thus moving away from the sun as a cloud of corona enveloping the stellar core. And we see one of these stellar cores in the sun's corona. You can see the gravitational vortex that it is causing in the sun's corona, connecting the object to the sun, and through which the object is drawing coronal plasma. Actually, not coronal plasma. It seems to actually be material coming from deeper within the sun, from the chromosphere. And here's another one of these objects, a recent capture of Scott Sion's, and we can see this seems to be quite a small object, and we can see the gravitational vortex that's connecting the object to the sun and through which it is drawing material from the sun. And this is an image from 2012 where we can see a stellar core also creating a gravitational vortex with the sun. And in 3 or 4 angstroms, you can see that the vortex does not have this dark appearance that we see in the 171 angstrom image, this one here, and the 193 angstrom image. Both of them, we can see this, the central portion of the vortex is dark. And we don't see that in the 3 or 4 angstrom image, suggesting that this, the material in the darker part of the vortex, the denser part of the vortex, comes from the chromosphere, because the 3 or 4 angstrom light is emitted by the top of the chromosphere. You may look at article 99 entitled Planet X and Stellar Structure for more details on the chromosphere being in the liquid phase. Now, if the stellar cores, which are about half the size of Jupiter, are obviously able to draw material from the sun through gravitational vortices, then we should expect larger objects which may be close to or even larger than the sun to be able to draw material through gravitational vortices as well, except that these gravitational vortices would be much larger and the objects would thus be able to draw a much larger amount of material. These objects would then be enveloped in the material they had just drawn from the sun, and they would thus look like what we call a CME as it moves away from the sun at high speed. And larger objects would exert a larger gravitational force, even though these objects are gravitationally weak and thus are only able to exert a weak gravitational force for their size and the mass that we can see they would have. They still exert a gravitational force on the sun. They will still create gravitational vortices, and a larger object will create a much larger gravitational vortex and thus be able to draw a much larger amount of material from the sun's corona and the chromosphere, most likely in a small amount of time. So in conclusion, CMEs seem to occur because stellar cores approach the sun and draw material from it through gravitational vortices. The smaller stellar cores create small gravitational vortices and draw small amounts of plasma. but larger objects will be able to create much larger vortices from a greater distance and thus produce a CME event when they leave the sun at high speed, whilst enveloped in a cloud of plasma which they have drawn from the sun. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.